Ventilation. This is the bane of everyone's existence. Single family, multifamily, high rise, it doesn't matter. What do I have to do? Yes, balanced ventilation. You have to supply fresh air and you have to exhaust. You have to supply to each living space and you have to exhaust from the kitchen and the bathroom. And if there's a laundry in the unit, you have to exhaust from the laundry. You have to put even your common areas through your ERV. So in a cold climate, you need heat recovery. You'll never meet your energy budget. And that efficiency needs to be at least 75%. The minimum ventilation rate is 0.3 air changes per hour. The occupant needs the ability, now these are the current conditions, but we have gotten special consideration to change some of these, and I'll explain why. Occupant ability to boost to higher levels when desired, and that boost needs to go to a minimum of 35 CFM in the kitchens and 24 CFM in the bathrooms. Okay, so these are the requirements that are on the Passive House websites. This is the basis. So what do you do? So let's talk about New York City Code. So in the New York City Code, you can either do intermittent or continuous, but since we're doing a continuous, we're going to look at those. We have to look at those flow rates. The minimum required air change rate is 0.35, so already you're slightly higher than Passive House right there, or 15 CFM per person, and you consider it's a number of bedrooms plus one, right, for code to count the number of people. In the kitchen, you either need 100 CFM if it's just an intermittent system, or you need a minimum of 25 CFM continuous if it's a continuous system, excuse me. If it's not a studio, if it's a one bedroom or more bedrooms, there is a caveat that if the kitchen is within 25 to 30 feet, there's a conflict between different codes, from the kitchen, you don't need to put ventilation in that kitchen, which actually helps quite a bit, and I'll show you why. Baths can either be 50 CFM intermittent or 20 CFM continuous. And then if you're using a continuous system, exhaust ventilation can dictate the rate. So if we're using continuous and the code says, well, it's at least 15 CFM per person, right? So I say, all right, it's a one bedroom. I have two people. I need at least 30 CFM per the code for supply air. But then if I look at my exhaust requirement, I have one kitchen and one bathroom. I need 45. So the greater of the two is what you need to supply. So for this little one bedroom, I need to supply 45 CFM. All right, so let's look at some numbers here. I can't see this on my screen, it's too small. So here's some pros and cons. I'll talk to you about the ventilation rates and what that equates to in a minute. What I wanted to show you was central versus local. So do you want to use 1 to 4 large central systems for your project and use chases, and then you just have your ERVs on the roof? Or do you want individual ERVs in each unit? And so there's major pros and cons for each of these. And I'm sorry, but I have to turn this way because I can't see it. So let's just go through the individual ones. So you have to have 2 penetrations per apartment on the facade because you have an exhaust and a supply. Now there are some ERVs on the market that have a concentric vent, but they are not efficient enough. There's basically 2 units out there that meet Passive House standards, and that's it. One's a US product and one's a European product. And we can give you information on that later. So you will, and both of those use 2 separate penetrations. Separate exhaust and supply, they need to be 10 feet away from each other on the facade. They can be vertically, horizontally, whatever, but they need to be 10 feet away from each other. If you have a small apartment, you may not have that exterior wall to get that penetration. And then your exhaust needs to be 2 foot from an apartment window and 4 foot from the neighbor. So there's some pretty strict requirements from the codes on where these penetrations can go. One of the pros is that the resident gets metered for that directly, whereas for a central system, you're going to do, the building's going to get hit on that. There's no slab penetrations, right? So all your penetrations are going out a side wall. They won't be able to go up. Your fans will never be able to handle it if they all went to the roof. The 10-foot facade separation issue is a con. The ceiling heights are an issue. If you have only 8-foot ceilings, you need to do some drop soffits so that you can run your ducting to where it needs to go. And if you want to see your ductwork, it's an aesthetic issue. You also need a hatch so that you can get, if the ERV is in the ceiling, you need a hatch, you need to be able to do maintenance on these. The filters need to be replaced, you need to be able to get to them. So there's those considerations. You can easily do continuous and boost flow in each apartment. It's very easy to set up. It's a simple push button control in the kitchen and the bath. They're set up to do this. You can do that all day long. It's been done in many, many, many projects. And you can get Passive House certified units, and they're available, okay? Or we know there's efficient enough units, I should say, on the market in the US. Compliance testing, we know how to do these. We've done them over and over and over again. Many homes in the US have been tested for these flow rates. And then you need to, the pros on this are maintenance, okay, real big. Every ERV should have its filters cleaned or changed every 3 to 6 months. So if you have 350 apartments, it's like painting the Brooklyn Bridge, right? You just start and keep going. Just, okay, now we're back to the first floor. So that's definitely a pro. Most managers don't like that at all. So the central ERV would be your rooftop or somewhere central in the building where you're going to hit multiple apartments with one ERV. The owner is on the meter for this one, okay? The floor space, there's floor space reductions, not necessarily floor height reductions, because you're probably going to run central chases down and then just duct off to the side. So do you need fire dampers for these? You have large slab penetrations now, so you've got to cut through your slabs. And you need to have fire-rated shafts. Continuous and boost is achievable, but very complicated. So if you're running at 0.3 air changes per hour, and one little apartment wants to boost, what's your 6,000 CFM ERV going to do? Right? Like, can it even do that? Can it even go from high speed, if the whole building went to high, which is not usual, but if everyone was in high, does it have the capacity to go from a low speed to a high speed with all the units? Do we have that capacity? Most fans don't have that range, and they don't have that control. So the complexity of the control system to offer boost operation is really high, really complex, and a lot of mechanical engineers don't even want to touch it. They're going to overbid the process because they're afraid they're not going to be able to get it to work. Variable flow rates are, let's see, rooftop ERV compliance. So we don't have any ERVs, central ERVs in the US that have been tested by Passive House. So what we have to do is, what we normally do is we take the apparent sensible efficiency for an ERV, say that it's 96%. We have to subtract 12% off if it's not Passive House certified. So that 96 ERV falls to 84%. So, okay, we can use that. It's better than 75%. But if I have an ERV manufacturer in the US that says I'm at 84%, now I'm under that 75% efficiency when I subtract 12% off of it, okay? So we don't have any that have been certified, and what they're gonna require is that we do some specialized testing in the field to verify that it's operating as it should be operating. So you can get all the way to the end of your project and get your ERV set up and do your testing, and maybe it's operating at 70%, which would be bad. So that's one of the cons of the central system. It's pretty heavily weighted there. But on the plus side, you just go up to the roof and you maintain those ERVs, right? So that's easy to get to. So these are really complicated issues in high-rise buildings. What we recommend, and what I recommend to my clients, especially with really tiny apartments, is that they do a constant volume system. No boost. So what you're going to have to do is you're going to have to evaluate, okay, what do I do to satisfy code? And what do I do to satisfy Passive House? Because they're not the same. And you may need to get special considerations from both parties to get somewhere in the middle, which we just recently had to do on a project. So we have some of our units meeting code, some of them lower than code, but even though they're lower than code, they're still higher than Passive House wants them. So, it's really a juggling act with this ventilation system. I think in a high-rise building, this is the one thing that's the hardest to accomplish well. And we still don't know if it's going to be done well, right? Because there's no precedence for it. We don't have anything tested. Now, I can tell you this, our firm has tested a ton of multifamily buildings, ventilation, exhaust-only ventilation buildings in New York City. We have data on it all over our website. The exhaust systems do not behave as they are intended to behave. You are rarely getting what you need on the bottom floors and almost always getting way more than you need at the top floors. So our feeling is, from the Passive House view, you're doing a supply system and you're balancing. So the likelihood that you're going to get a more balanced system is much, much higher because you don't have to overcome these pressure differentials in the building. The building envelope will be much tighter, your stack effect will be less, and by supplying and exhausting from the same space, the chances for success are much higher. But you also have to make sure that the air sealing is really spot on. Like every nook and cranny in that ductwork needs to be well air sealed, okay?